Now that we know how to solve an equation with a radical, we're ready to handle more involved equations that require us to isolate the radical before we remove it. Our first step for solving problems with radicals is to solve for the part with the radical. And that must be done first before we square both sides or cube both sides, depending on the problem. For example, if we had 4 plus 2 square roots of 2x minus 1 equals 2x, we can't square both sides until that radical part is all alone. So we solve that as if that was the variable. We can subtract 4 from both sides, which gives us 2 times the square root of 2x minus 1 equals 2x minus 4. And then I can divide both sides by 2. And when I do, that's going to divide each and every term by 2, which leaves me with the square root of 2x minus 1 equals 1x minus 2 after reducing. Now that the radical is alone, now we can solve it like we saw in the previous video. First, noting that the square root equals x minus 2. That means the x minus 2 has to be greater than or equal to 0. And by adding 2 to both sides, we know x has to be greater than or equal to 2, no matter what. OK, that's what we have to watch out for. We're ready to go for solving it. We get rid of a square root by squaring both sides. When we square both sides, it clears the square root, leaving behind 2x minus 1 on the left. On the right side, notice that's a binomial. We can't just square the two pieces. You square the first term, and then don't forget the middle name by multiplying them together, and that happens twice. So I have negative 2x and negative 2x, which makes negative 4x. And then I square the last term to get plus 4. Now we can continue solving by making it equal to 0 by subtracting 2x and adding 1 to both sides. When I do, I get 0 equals x squared minus 6x plus 5. And that factors to x minus 5 times x minus 1. Well, by setting each factor equal to 0, we can see that x is equal to 5 or 1. But before we get too excited about our solutions, we remember that x has to be bigger than 2. So the 1 is a false solution, an extraneous solution. It has to be thrown out, leaving x equals 5 for our solution. Let's try one more example so we can see that worked out. Let's try 2 times the square root of 5x plus 1 minus 2 is equal to 2x. Again, because the square root part is not alone, we have to get it alone by eliminating the other pieces. First, I'm going to add 2 to both sides. That's going to give us 2 square roots of 5x plus 1 equals 2x plus 2. Then I'll divide off that 2 in front of the radical. And when I do, I have to divide each and every term by the 2. So I get the square root of 5x plus 1 equals x plus 1 after I reduce. Again, when the square root equals something, that something the square root equals, x plus 1, has to be greater than or equal to 0. So subtracting 1 from both sides, I see x has to be greater than or equal to negative 1. I'll have to be careful of that with my solution. Now we can clear that square root by squaring both sides. When I do, I get 5x plus 1 equals x squared. And then, of course, 1 times x is x. And that's going to happen twice, giving me 2x plus 1. This is a quadratic, which we solved by setting it equal to 0 and factoring. So we'll subtract 5x from both sides. We'll also subtract the 1 from both sides. So we have 0 equals x squared minus 3x. Factoring, all we can do here is factor out the greatest common factor of x, leaving behind x minus 3 is equal to 0. And setting each factor equal to 0, the first factor, x, is 0 at 0. The second factor, adding 3, gives us 3. And before we say that's our solution, we double check, are our solutions greater than or equal to negative 1? Both of these are greater than or equal to negative 1, so both of them work. and we have our final solutions. So solving with radicals, our first step is to get the radical alone. Then we can square both sides, or whatever the index is. And finally, make sure you watch out for those false solutions. Whatever the square root equals has to be greater than or equal to 0. It's your turn to practice some of these. Take a look at the homework and let your instructor know if you have any questions.